Hello, and welcome to the last part of our series on data science. In this series, we have studied different terminologies within data science. For example, we have talked about machine learning, big data, data mining, knowledge discovery in databases, data analysis, and data analytics. We have explained the meaning of each one of them and how all of them are placed in the context of data science. Then, we studied the data science workflow with its many building blocks, and we presented the main careers in the field and how each one of them fit in each of the building blocks of the data science workflow. In this class, I am going to present to you the main courses that you can find within data science. The idea here is to present the courses mainly focused on the disciplines that they cover instead of the technologies that are presented in the courses. And the reason why I decided to present it this way is because the technologies evolve. So you may have any specific framework or tool nowadays, but in a few years, these tools may be obsolete. So the focus here will be on the topics covered in each one of these courses. I will start presenting the core disciplines that compose data science, and then I am going to present some other courses that are part of the area and that are also offered in many schools around the world. It's also important to acknowledge that if you look at different schools, you'll find variations of these courses. And as most of these courses are offered as elective disciplines in formal studies, there may be some great variations in the topics covered in different schools and by different professors. I listed here 9 core disciplines within data science. The first one is a discipline that is focused on preparing the students mainly with the mathematical and statistical background in order to become a data scientist. As we've seen in the previous part of this series, it's very important that the data scientist has a good knowledge, has a good background of mathematics and statistics, of course, of some specific areas of mathematics and statistics. And this is covered mainly in this first discipline that I'm presenting here. Then we can have a course on the introduction of data science, on exploratory data analysis, though it's much more common to find courses on data visualization than courses on exploratory data analysis. If you remember, when I discussed EDA in the previous parts of this series, I emphasized that EDA focused on descriptive analysis, data visualization, and dashboard design. We also have courses on machine learning, courses on data acquisition and preparation that are also sometimes called courses on data engineering, standard courses on AI. Usually the courses of AI are more topic-based in the sense that the professor is going to choose what topics he or she are going to cover in the course. We have courses on neural networks, courses on deep learning, and on natural language processing. In summary, I would say that these are the 9 core courses that we could have on a data science program. Of course, we can think of predictive analytics, we can think about other courses, but I would say that these ones would form a consistent program on data science. Now, let's have a look at each one of these courses in a bit more detail. This discipline on the mathematical background for data science, I would cover some applications and a general overview, and you will see that for all the courses that I'm going to present to you here. So I'm not going to detail that for all disciplines that I present. Then we have concepts on linear algebra, some basic concepts of calculus, probability, statistical inference, regression, Bayesian statistics. We can also have some topics on search and optimization, mainly if you're going to cover subjects like genetic algorithms or any type or mathematical programming that are techniques used for solving optimization problems and that require this background knowledge on search and optimization. And also something on graph theory would be very helpful for a better understanding of neural networks and of different ways of modeling, for example, texts. For an introductory discipline to data science, I would present the data science workflow, the processes of data acquisition and data preparation, from data integration to dealing with missing values to data normalization and all the steps necessary to prepare your data for analysis. Then I would include something on descriptive analysis, data visualization, and all the standard machine learning approaches, including clustering, classification, regression, association rule mining, and so on and so forth. For a course on exploratory data analysis, we have already covered that several times in the previous parts of this series, but I would summarize by saying that the main steps here, the main topics that should be covered in this discipline, I will include data description and preparation as well, just as we did with the Introduction to Data Science course. Then I would go to the descriptive data analysis, data visualization, and dashboard design. For the discipline on machine learning, when we talked about machine learning, we said that machine learning is usually more focused on the learning algorithms themselves, such that a machine learning discipline would have to emphasize the main learning paradigms: supervised learning, unsupervised learning, reinforcement learning, and semi-supervised learning. At least these four main learning paradigms should be covered here. And then we could use an organization based on the tasks like clustering, classification, regression, association rule mining, recommender systems, or we could organize this discipline based on the learning paradigms. For example, dividing it in unsupervised learning, supervised learning that would cover these two, unsupervised would cover clustering and association rule mining, supervised learning would cover classification and regression, recommender system is more of an application or a specific task, and you can do recommender system using both unsupervised and supervised learning. And this means that there are different ways of organizing this discipline. Actually, as I said, there are different ways of organizing all of these disciplines. What I'm presenting to you here is one form of organizing disciplines such that they contain the main topics that, in my view, should be covered in each one of these disciplines within a consistent data science program. And this discipline should be concluded with some background on model evaluation, on model selection, and some things about the deployment of the solutions or the algorithms presented before. A discipline on data acquisition and preparation is sometimes also called the discipline on data engineering. It would have to talk about data sources and data formats, data collection and information retrieval, all the data preparation steps, including integration, transformation, sampling. It should cover some things on descriptive analysis and visualization, data quality and ethics. It's very important nowadays to discuss ethics in data acquisition and the whole data science process. And finally, data management and data governance. A discipline on artificial intelligence, as I said, is a more topic-based discipline that we can cover many things, depending on the trending topics that we have in the field at the moment. Of course, you can cover the more basic, what we would call the good old-fashioned AI, but it's very important that a discipline on AI cover the most recent topics in the field. In this direction, what I did here is I took these 5 first topics here to cover the more standard part of AI, including search and optimization, knowledge representation, expert systems, and agent-based systems. And then the last 4 topics here are more recent topics, including machine learning, deep learning, natural language processing, computer vision, artificial intelligence applied in games and robotics, and topics discussing ethics in AI. This is an introductory course on neural networks. I would start by covering some biological inspiration of how the brain works, what's the structure of the neuron, how it processes information, the neural architectures the main neural architectures that we have in the brain, and how they inspire the development of artificial neural networks. The course would evolve into the description of network architectures and learning paradigms, the same way that we did with the Introduction to Data Science and with the machine learning courses as well. Then I would cover unsupervised neural networks, single-layer networks, multi-layer networks, recurrent and Hopfield networks, and deep neural networks. Of course, while covering some of these types of networks here, I would be covering the supervised networks as well. Just as we did with the machine learning discipline, we could also divide the neural networks discipline into unsupervised networks, supervised networks, and recurrent networks. For a deep learning discipline, I would start by reviewing the standard neural networks that we saw in this course here, which could be a prerequisite for a course on deep learning. And then I would move into convolutional neural networks, recurrent neural models or recurrent neural networks, the generative models, the deep reinforcement learning, and we could cover different learning approaches that are very common in deep learning, like transfer learning, federated learning, multimodal learning. All of these learning approaches are very common in deep networks, and they are usually not covered when we are talking about the standard neural networks. Finally, the discipline on natural language processing. This discipline could start by talking about text processing and tokenization, followed by text structuring, including vector space models, grammar-based models, distributed representations, and these two topics would be part of text mining. Then it would go into language modeling, word embedding, neural models for natural language processing, named entity recognition, sentiment analysis and opinion mining, language generation, and machine translation. Again, this is just one way of organizing and selecting some specific and important topics for each one of these core disciplines in data science. Let's talk about now some other disciplines that could compose a data science program. Here I selected a discipline on data mining, a discipline on KDD, a discipline on text mining, computer vision, probability and statistics, and predictive analysis or predictive analytics. As we discussed previously, KDD is the whole process of analyzing data, from data capture to the validation of your solution. And the literature usually considers data mining as one step of KDD. However, it's very common to use data mining as a synonym to KDD. In the organization that I presented here, they basically have the same components, including data preprocessing, descriptive analysis, clustering, classification, regression, rule mining, and anomaly detection. But in the KDD course, I added some topics, including text mining, sentiment analysis, time series prediction or time series analysis, web mining, and anomaly detection. A course on text mining should cover all the text preparation steps that we also have in an NLP course, but also emphasize text retrieval, information extraction, the processes of feature engineering, and these topics here that are common in NLP disciplines as well, like sentiment analysis, opinion mining, topic modeling, named entity recognition, text classification, and mining. Computer vision can be seen as a discipline within data science or within artificial intelligence. I believe it's worth mentioning it here because it has plenty of application in the field. In this discipline, I would cover image filtering, feature extraction, segmentation, transformation, object detection, and recognition. All these are part of the more standard computer vision course. I would also add a strong component on neural networks and deep learning because they have advanced the field significantly over the past years. This discipline on probability and statistics has a strong convergence with that discipline on the mathematical fundamentals for data science, with the difference that this course here is more focused on the study of probability and statistics and would not cover topics like graph theory, search and optimization, linear algebra that are very important for the understanding of different data science techniques and applications, but that would not fit in a course on probability and statistics. Finally, a course on predictive analysis or predictive analytics would have to necessarily focus on the predictive approaches, including classification, regression, ensembles, time series analysis, neural networks, and deep learning. To conclude this part, I would like to make some intersections so that we can understand the commonalities of some of these courses. For example, if we take machine learning, KDD, predictive analytics, and data mining, all of them will have to cover clustering, classification, rule mining, regression, and data preparation. And the reason why I'm presenting it is because if you're either planning a program or data science or planning to attend a program on data science, it's very important that you know what you're going to find in each one of these courses and what are the intersections so that you can choose and you can discuss with the professors what you're going to find in each one of them. Thank you for watching and see you in other courses or series in this channel.